We're going to begin our unit in probability. We're going to start with learning how to count the different outcomes in math. The outcomes occur from different events. Our essential question is, how do I count outcomes in math? We're going to learn a few different ways to do that. Today we're going to focus on one method in particular. The vocabulary below, there's going to be 4 vocabulary words for you. I will briefly describe them, but as always, feel free to pause the video to continue writing them into your notes. Sample space. Sample space is the set of all the possible outcomes of an experiment. There will be multiple different outcomes when you are solving a probability problem. For instance, if I had a number cube and I rolled it, an outcome could be 6. The sample space would be all the possible outcomes I could get. I could get a 1, a 2, a 3, a 4, a 5, or a 6. So my sample space is 1 through 6. The outcome is the possible result of an experiment. So the outcome is maybe the 6, or maybe just the 2. It is just one of the options that we could get from the experiment. An event is a set of outcomes in an experiment. It's a subset of the sample space. So I may say, what is the probability of getting even number when rolling the number cube? Well, that would be 2, 4, and 6. There's a probability of 3. The event would be just my even numbers of that number cube, which is a subset. It's part of that sample space. Tree diagrams are a very effective way to figure out all the different outcomes you have that create your sample space. Notice here that it's the outcomes of an event which creates your sample space. All 3 of those vocabulary words are used right there. We have, in this case, we went to a ice cream shop, we'll say, and we were going to get ice cream. They only had 4 options of ice cream flavors: chocolate, vanilla, strawberry, or mint. And then we had the option between a sugar cone and a waffle cone. The event might be, how many different ways can I get a sugar cone? However, the sample space is all of these. Notice what I did in order to make this tree diagram. Well, we'll make some here on the next few slides. But we listed our 2 different events. We have the cone style on this side, and over on the right-hand side, we have the flavor of ice cream. That's the other option we have. My sample space in this case, I would write then off to the side, would be a sugar cone with chocolate, or a sugar cone with vanilla, a sugar cone with strawberry. Oh, there it goes finally. It would be a sugar cone with chocolate, sugar cone with vanilla, sugar cone with strawberry, sugar cone with mint. And then the same thing would occur down here, except it's not a sugar cone. It's a waffle cone with chocolate, waffle cone with vanilla, waffle cone with strawberry. Excuse me in a second. Waffle cone with mint. My sample space then included 8 different options. My event maybe was just these 4 options, because I maybe only wanted the sugar cone options. And each one of these is an outcome. There were 8 different outcomes for this. So that's how we use those vocabulary words. All right, so you need to determine the size of the sample space. How many different outfits can we create? So here we go. We have Jennifer. She has 3 different skirts, and she has 2 different tops. How do I make a tree diagram using this? Well, I know right here that this is a red skirt. Oh, that marker's not going to show up on the next one. And this isn't red. Oh, my goodness. This is a green skirt. This is a red skirt. And this is a blue, or purple, I suppose, but we'll go with blue since I already have that written down. So when I'm creating my tree diagrams, I can do this one of 2 ways. I can start with my skirts. So I go to my closet and I'm going to pick out my skirts. My options are 3 options here: green, red, blue. Again, I'm creating my sample space here. After I choose what I want to wear for skirts, I need to look at what do I have available for shirts. If I picked the green skirt, I could pick between the purple and the tan shirt. Those are my options. If I picked the red skirt, I can still pick between the purple and the tan shirt. And if I had the blue skirt, I can still pick between the purple and the tan shirt. So my outcomes, the possible outcomes that I have at the end, are green with purple, green with tan, red with purple, red with tan, blue with purple, and blue with tan. I have 6 different outcomes that make up my sample space. So everything in blue here is my sample space. There are 6 different outcomes that are there. I might say, how many outcomes are there in the event that I wanted a green skirt? Well, then I would say, well, there's only 2 options for me to have a green skirt. So that would be a specific event within there. This is where we start to get a little confused because we see 4 coins here. And so all of a sudden we think when we're making this tree diagram that we have to have 4 coins. And this is where you have to read and see what it's asking you. The question says a dime and a penny are tossed. So in this case, this is just like my shirt and my skirts, except I don't have a shirt, I have a dime, and I don't have a skirt, I have a penny. And I want to know what is the sample space. Well, with my skirt, we had green, red, blue. With my dime, I don't have green, red, or blue. Whoops. I have heads or tails. And then with my penny, I don't have purple or tan like I did with the shirt before. I have, again, heads or tails. Heads or tails. So my sample space in this case would be heads, 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 tails, tails, heads, tails, tails. My sample space is 4 in this event right there. And all the possible outcomes are those 4. Notice how I decided to split these up. I asked myself, similar to the skirt and shirt problem, well, what do I have? I have this, and my options were as listed below. So in this case, we need to determine the outcomes of getting a heads or a tails. I have a quarter, a dime, and a penny. So this case, it's almost like I have a shirt, a skirt, and shoes to pick from. So I could, let's see if I can move these figures over just a little bit here. Oh, they're separate. Oh my goodness. Okay, those are together. So I know that in this example, I have a quarter. I'm just going to put a Q to save some space. And what are my options for my quarter? Just like what were my options to get a skirt? Well, in this case, I don't have colors. I have heads or tails. But then I also have a dime. And what are my options for a dime? Well, I could get heads or a tails. If I happen to have gotten a tails with the quarter, that's not going to change what I can get with the dime because the dime is still independent. I can still get a heads or a tails. But in this case, it's different because I also have the penny that I need to flip. If I flip the heads with the quarters and the heads with the dime, it doesn't impact the options for my penny. It's not going to automatically make it do one or the other. I still have heads or a tails for that option. And same thing, if it flipped on the tails for the dime, I'm still going to have both options here for the penny. So I have to list out all the possible outcomes that could potentially occur. Now that I have my tree diagram made, I can list out all the different outcomes that I could have. And I do that by just following the line. If I start with heads, went here, my one option is heads, heads, heads. Then I could go, notice I still have this tails that I could choose from. But I still have to follow this path in order to get to this branch and come down. So that would be heads, heads, tails. Now I'm going to stick with the heads still, because what if I got a tail with a dime? So I'm going to follow this branch down and then up to heads. So that was heads, tails, heads. But I still have that other branch, so heads, tails, tails. Now that took care of if the quarter happened to have heads. This would be maybe just one event of if the quarter was to get a heads. Now I'm going to show, well, what if the tails was for the quarter? So I'm going to follow tails, head, head. And then tails, heads, tails. That takes care of that branch. And we have one final branch to look at here. What's one final color I don't have? Let's try black here. We're going to start at tails. And if the dime had tails, then we go to heads. So tails, tails, heads. And then tails, tails, tails. And those would be the different outcomes that we could have that create our sample space. So our sample space was created by all those different outcomes. We just did that. Why is that there twice? I'm not sure why that's there twice. We're going to keep moving on. All right, so now we have a different type. We're going to a restaurant. We're going to have different meal options from this menu. In this menu, we have a choice of appetizers, soup and salad, main dish, beef, chicken, and pasta, and dessert, which is cake and pie. I'm going to minimize that a little bit so we can see it from the screen in its entirety. So in this case, we're switching it up a little bit, but this is like my quarter, my penny, and my dime. I just have 3 options for this one instead. So when I create my tree diagram, in order to not make a mistake, I just like to label things. So I'm going to say, here's my appetizers. And what are my options for appetizers? Soup and salad. Well, I can't put S and S because that's the same. So I'm going to go SP for soup, SL for salad. Those are my only 2 options. Now, I'm going to create the event that only, let's say I get soup. I still can get a main dish. What main dishes do I have to choose from? Well, if I get soup for an appetizer, I can still choose between the beef, the chicken, or the pasta. And after I get my main dish, well, then I get to choose my dessert. My dessert does not depend on my appetizer, nor does it depend on my main dish. For my dessert, I could very easily get cake or pie if I got the beef. But I could also very easily get cake or pie if I got the chicken. Or I could very easily get cake or pie if I got the pasta. Now, let's say that I didn't get soup at all. And instead of all of that, I got the salad. Well, if I got the salad, then my main dish is going to be beef option, chicken option, or pasta option. And then my desserts are still open for my choice. I could get cake or pie. If I had the chicken, I could get cake or pie. And if I had the pasta, I could get cake or pie. So those are all of the different outcomes that I could get from my choices here. My sample space then is going to be all these different options. So I could get soup, beef, cake. I could get soup, beef, pie. Soup, chicken, cake. Soup, chicken, pie. And again, sometimes it's helpful if you draw these lines as you go. I'm not going to keep doing this because it makes it messy and just takes a little bit longer. I could get soup, pasta, cake, or soup, pasta, pie. So notice I have 1, 2, 3, 4, 5, 6 different options in this case. 1, 2, 3, 4, 5, 6. I'll have similars down here, except all of these would be salad instead. So I could have salad, beef, cake, salad, beef, pie, salad, chicken, cake, salad, chicken, pie, salad, pasta, cake, salad, pasta, pie. Another 6 options there. So my sample space has 12 different choices. 12 different choices in my sample space. Maybe the event was I'm just going to get salad. Those would have 6 options, and each one has an outcome. So there are 12 different outcomes within this. Some people have asked, well, what if I didn't want to start with appetizers? What if I wanted to start with the main dish? And that's okay. You're going to get the same options. They'll just be in a different order, but it's still going to be the same thing. So let's say I started with the main. And I'm going to do this one a little bit quickly because I don't want to take up all of your time. But let's say that my mains, I had beef, chicken, pasta. And then after that, I'm going to go to the dessert. And I have cake or pie. And same thing here. Cake, pie, cake, pie. And then I did my appetizer. And from here, I could have super salad, super salad, soup salad, soup salad. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12. There are still 12 options here. They're just organized in a different way, and it's almost like I could put these backwards, but they're all still there. So in case you wanted to just create it a different way, making sure that you still separate things, that's okay. All right, so I want you to try this one. A restaurant offers a choice of 3 types of pasta with 5 types of sauce. Each comes with or without a meatball. Go ahead, pause the video, try it. Now that you're back, what I want you to see is that we have a few different things going on. First of all, we have pasta, we have sauce, and we have meatball. Those are our 3 different categories up here. Pasta, sauce, meatball. A lot of people miss the meatball. For pasta, I have 3 different types. I don't know what they are, but I have type A, type B, type C. For my sauce, I have 5 different types. Oh my goodness, this is going to take a while. 3, 4, 5. I have type 1, type 2, type 3, type 4, or type 5. And I'm just going to see, I sure can. We're just going to clone this guy. If I got this one, it could be there as well. Or if I got this, it would be that as well. From there, I can have meatball or no meatball. So the answer here is going to either be meatball, no meatball. So there are 2 choices here. And we're going to see if we can do the same thing. It's going to become crowded on each other, but we'll do what we can. So that's going to go here, and there, and there, and there, and so on and so forth. Oops, I might have to move that one up a little bit. So notice where this isn't difficult, it's just going to take up space, and it takes a little bit of time to draw out. I probably could have drawn these faster than I'm dragging them, but that's the case. And if you had larger space or a thinner pencil, obviously I could have used more space here to better show what was going on. And then all my options, in this case, let's see if we can get to fit them all. My pasta, it would have been pasta, let's see, I don't have room. We'll go on this side. I could have had pasta A with sauce 1 with meatball, pasta A, sauce 1, no meatball. Pasta A, sauce 2, meatball, pasta A, sauce 2, no meatball. I'm not going to list these all out. Hopefully you did. But your sample space then should be around 30. You should have 30 different types listed here in your sample space. There'd be 30 different lines of options that you could eat if you had 3 types of pasta, 5 types of sauce, and a choice between a meatball or no meatball. Your job is to take the time to draw out the tree diagram. Draw out each different column, whether it's skirts column, appetizer column, socks column, dime, penny, number cube, roll 1, roll 2. Take the time to do that. At the end, tell us how many outcomes you have. I do want to offer up some information regarding question number 1 because I've seen a lot of kids throughout get this problem wrong. What that number question is saying is that you are rolling a cube twice. So you have to think about, okay, what are my options here? And my options are roll number 1. If I'm rolling a number cube, don't just look at the picture. Use your knowledge of a number cube. The picture only shows numbers 1, 2, and 3, but you know that there's more to that number cube that you can't see. What are my options for roll number 1? And then when I pick it up, what are my options for roll number 2? And I'm just giving you this hint because I've seen a lot of kids set this one up inaccurately. All right, have a great day.